Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 11, Lesson 5 on variation in a data set. So, it seems weird that this comes as Lesson 5 given that the whole point of statistics is to answer statistical questions that involve variation, right? And variation is just this idea that when we go out and we take data, right, from subjects, people, cars, animals, whatever, right? When we take data, not all the data values are the same. That is variation or variability in the data. Today, what we want to do is actually look at how to measure how much variation there is in a data set. Because it's one thing to be able to say, well, the average salary for lawyers is $120,000. It's another to talk about how spread out the data is or how spread out salaries are for lawyers. Because if, almost every lawyer makes $120,000 a year, that's one thing. It's another thing, though, if some lawyers are making $20,000 a year, and then to balance that, some lawyers are making $300,000 a year, right? So we're going to be looking today at one important measure of the variation within a data set. So let's talk about it. We often use statistical measures, a statistical measure, to summarize a data set that is most often a measure of center when we use one. So like the mean, the median, the mode, etc. Right? So let's just kind of review those without me getting too much more tongue-tied. Let's review those in exercise number 1. 6 students were asked how many text messages they sent over the weekend, and their responses were the following: 4, 4, 4, 8, 9, 13. Find the median, the mean, and the mode number of text messages. Label your measures. All right, fantastic. I'd like you to pause the video right now, figure out the mean, the median, and the mode for that data set. Should be pretty simple, and then we'll revisit and talk about what we got for those statistical measures. All right, let's do it. Well, I'm gonna take care of the easy one first, the mode, right? 4 shows up 3 times in this data set. It shows up more than any of the other ones. So the mode, the one that shows up the most often, is 4. All right, now I'm going to take care of the second easiest one, the median, right? Now, if we had an odd number of data values, we would literally just kind of look at this data set and find the one that was right in the middle. Because we have an even number of data points, right? We have 6 of them. There should be 3 that are below the median and 3 that are above the median. That means that the 2 most inner numbers, the 4 and the 8, right? I need to find their average. Finding the average of 2 numbers will always find the number that is halfway in between them, right? So sometimes you can just figure out the median by thinking about it, right? So the number that is literally in the middle of 4 and 8 on a number line is the number 6. Like if this had been 4 and 6, not 4 and 8, I wouldn't have even done this calculation. I'd be just like, oh, well, it's 5. 5 lies right between 4 and 6. And likewise, 6 lies at the midpoint between 4 and 8. And if you can do that in your head, more power to you. But now the hard one, so to speak, the mean, right? And the mean is, of course, more difficult because you've got to add up all the numbers without making a mistake, and then you have to divide by how many numbers there are, hopefully also without making a mistake. So let's do the addition together. 4 plus 4 plus 4 is 12, right? 3 fours is 12, plus 8 is 20, plus 9 is 29, plus 13 is 42. I had to think about that one a little bit in my head. So the sum of all the text messages is 42. So now the mean is going to equal 42 divided by 6. So the mean is 7 text messages, right? The mode, when it exists, will always be one of the numbers in the data set, right? It has to be. It's the data point that shows up the most often. On the other hand, the median and the mean do not have to be part of the data set, and in this case, they aren't, right? A median of 6 text messages, a mean of 7 text messages, neither one of those showed up in the data set. So, again, measures, statistical measures, are numbers that we use to help us answer statistical questions, right? So, if the statistical question was, how many text messages did my friends send this week? right, or this weekend, sorry, then any one of these three would be a great statistical measure to let them know. Well, the most often number was 4, the mode. The median number they sent was 6, or the average/mean number they sent was 7. Okay? So that's all good and well, but the middle number, the measure of the center, isn't always what it's cracked up to be. And let's talk about that in the next exercise. So two data sets can have exactly the same mean, but still be radically different in how much variation, difference, there is in individual data values. All right, so we can definitely have two data sets that have exactly the same average, and yet the answer to the statistical question for the two data sets should be kind of different. Let's take a look at a classic example in exercise number 2. Samples of 20 people each were taken from 2 movies to determine the ages of the people watching the movies. In both movie number 1 and movie number 2, the mean age was 28 years. Letter A, which movie appears to have greater variation in the ages of the people who attended? Explain your choice. So let's first, before we even get into that, let's take a look at what we have. We've got these 2 dot plots, movie 1, movie 2. The dot plots are on the same scaled axis, right? They go from 15 to 45 years old, 15 to 45 years old. Apparently these movies do not apply to people that are kind of my age and older. All right, but here are the distribution of 20 people that saw these movies. And for both of them, if you added up all of the ages and divided by 20, what you'd find is that the average or mean age was 28 years. And yet, you can even see, just looking at the dot plots, that these are 2 very different data sets. Which one of them appears to have more variation in the ages of the people who attended? Pause the video now, write down which one you think it was, and how you determined that by looking at the 2 dot plots. Well, I'm hoping you said movie 2. Right, let me bring this up just a little bit. Now, how you would explain that, well, that's a little bit up to you, right? For me, it's as simple as this. They take up more of the number line. Literally, the data set is wider for movie 2 than it is for movie 1, right? The ages for movie 1 just go this wide, right? That's how wide of a distribution of ages we have. If we bring that over here, right, just as a comparison purpose, right, this data takes up way more space on this number line. And we oftentimes talk about the width of a data set. But I'm going to just say the data takes up more of the common number line. Than movie 1. Right? Just takes up more space, right? There's no ages here that are below like 23 years old, but we get some teenagers in here, right? And there's no ages in here that are above 36 years old, and yet we've got a few of them out here, right? This brings us into a very important and a pretty easy measure of variation within a data set, what's known as the range. So let's talk about that in B. For each movie, find the minimum, the maximum, and their difference, known as the range. All right. This actually, for some reason, says for each move. It's really for each movie. For each movie, find the minimum, the maximum, and their difference, known as the range, right? So that's easy enough. Let's take a look at it for movie 1. Okay, for movie 1, the minimum value is 23. We can see that just by looking at the dot above which it is. So that's 23, right? The maximum value for movie 1 right here is at 36, okay? And then the range. And the range is really all of what it's about today, right? The range is how wide the data set is. And we calculate that by simply taking the maximum and subtracting the minimum. Let me just bring this up for a second. The range is 36 minus 23, or 13, right? And really, the range truly actually has units, right? It's 13 years, right? So the minimum is 23 years old, the maximum is 36 years old, and the range is 13 years. There's a 13-year range of ages of people that attended this movie. Now what I'd like you to do is do the same for movie 2, all right? Let me actually bring this up here so that we can see those dot plots again. Find the minimum, the maximum, and the range for that data set. All right, simple enough to find the minimum and the maximum. The minimum, right, the dot that's farthest to the left is 18, right? The maximum, the dot farthest to the right, is 41. All right, the range is going to be 41 minus 18 with a nice red subtraction mark there, still red. All right, so the range is 23 years. All right. And so it's much wider. You can literally look at the range as being how wide the data set is, how spread out it is, right? And how spread out it is then is telling you at least a little bit about how much variation there is in the data set, right? Doesn't tell you anything at all about the central number, but you could imagine, right? If the statistical question was, how old are people, let's just confine ourselves to movie 1, right? How old are people that go to see this movie, right? Nice statistical question. You could say something like, well, you know, the average age was 28 years old, but there was a range of 13 years in the ages of people that attended the movie. Versus, how old are people that go to movie 2? Well, they're also 28 years old on average, but there's a range of 23 years in the ages of the people that attend that movie, right? So that range tells us that there's more variation in the ages of people that go to this movie than in the ages of people that go to this movie. All right, let's keep working with this idea of variation. Now there's many ways to measure variation in a data set, all right? But the easiest is by far the range, which measures, as I mentioned, how wide a data set is. The range tells us how wide a data set is, and it's simply found by taking the maximum data value and subtracting the minimum data value. Whenever we subtract one number from another number, we find the distance or the width between the two numbers. So that's what the range tells us. And let's work with it again in exercise number 3. Ian is trying to answer the question, how many minutes of television do kids watch on Saturday mornings? I think that's a pretty good question. He asks 25 of his fellow 6th graders and collects the following data. Awesome, right? Letter A asks us to fill out the frequency chart and construct a histogram of this data on the grid provided. All right, so that's easy enough. In fact, I even made it easier for you because I put the data in ascending order, right? So it's going to make hopefully filling out this, right, this frequency chart, histogram frequency chart, and then therefore drawing the bar chart a lot faster. So pause the video now, and why don't you go ahead and fill this out and then construct the histogram on that graph as given. All right, let's go through it quickly. Here we go. We've got 31, 35, and 39 all fall into this category for a frequency of 3. 41, 41, 43, and 49, those 4, 1, 2, 3, 4, fall into that category. 52, 56, 57, 57, 59, 1, 2, 3, 4, 5, fall into that category. 60, 62, 64, 65, 65, 67, 68, 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, fall into that category. 1, 2, 3, fall into the 70s. 1, 2, fall into the 80s. And just one person is watching in the 90-minute category. All right, so simple enough in terms of finding their frequencies. Again, when the data is all kind of mixed up at random, it becomes a little bit more challenging to find these numbers. But now we can use them to construct our histogram. As a reminder, right, we have this axis break on the histogram because our categories didn't start at 0. Although I do think this is one where we could have had a category start at 0, right? We could have actually had some kids that didn't watch any television on Saturday morning. It's kind of hard to imagine, but I can kind of picture it a little bit. You know, maybe the child isn't feeling well or something. I don't know. 30 to 39, we've got these 3 students who are watching, right? 40 to 49, we've got 4 that are watching. 50 to 59, there's our 5. Seems to be going up in a very regular pattern. 60 to 69, we've got 7, so a few more there. 70 to 79, 3. And then 2 and 1. There we go. Nice histogram, right? Illustrates what's going on. You know, we can quickly look at it, get a picture of what the answer to our statistical question might be. There's a lot of kids that are, you know, watching 60 to 69 minutes. Kind of makes sense, right? You know, you might have a couple half-hour shows, or, you know, maybe 3, you know, 25-minute shows or something like that, although then you'd be falling kind of into this category. Anyway, let's take a look at letter B. What is the median number of minutes watched? The median number of minutes watched. All right, not the mean. Thankfully, I'm not going to ask you to add up all of those times and then divide by 25. That'd be kind of a beast. I think I'd want a calculator for that. But the median's not so bad. Let me actually get rid of all my kind of hash marks there so that we can take a look at that a little bit better. And let me get rid of that guy. All right, so how do I want to find the median here? I've got 25 data values. Why don't you pause the video and try to find the one that's right in the middle? All right, now remember this trick. When I have an odd number, right, 25, then if I subtract 1, I get 24, and if I divide by 2, I get 12. That means, right, what do I do with that 12? That means if I go 12 this way, and 12 this way, there'll be a number right between those 12 that's my median. So literally, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there is my median, right? I've got 12 below, I've got 12 above. Now granted, you could say to yourself, well, another way to do it was maybe take 25 and add 1, get 26, divide by 2, and that would tell me that the median would be the 13th value. That's fine as well, right? Or you can do the trick of literally just kind of counting them off from both ends, right, until you get to that middle number. That works okay as well, as long as you count carefully. Anyway, one way or another, my median is equal to 60, right? And that would be a great sort of like answer to the statistical question, right? If somebody said, hey, how many minutes does a typical like 6th grade student watch television on a Saturday morning? And you came back and you said, well, the median amount is 60 minutes, right? Not only that, it's an hour, so that sounds perfect. But it wouldn't tell us how much variety there was in the data set. It would only tell us that, like, well, typically somebody might watch around 60 minutes. But let's figure out the range for this data set. Why don't you pause the video now and calculate the range? Well, it's pretty simple, especially when data is arranged in this nice ascending order, because the minimum is 31, the maximum is 95, and so the range is 95 minus 31, or 64 minutes. And I'm going to throw units on that, because there are units on things like measures of center and measures of spread, right? So that's even more informative, right? If now somebody said, well, how many minutes of television do typical 6th grade students watch on a Saturday morning? You could say, well, the median amount for my data set was 60 minutes, but there was a range of 64 minutes, meaning that to go from the lowest number of minutes to the highest number of minutes would be 64 minutes, right, in that interval. Okay. Again, the range, very, very easy to calculate, and also gives us a wonderful piece of information to answer our statistical question with. How wide is our data set? Let's look at one more issue involving the range in exercise number 4. High temperatures in March can vary widely. In a particular March in upstate New York, the range of high temperatures was 27 degrees Fahrenheit. If the maximum high temperature was 59 degrees Fahrenheit, what was the minimum high temperature? Awesome. Well, I'd like you to pause the video now and see if you can figure this out. Well, literally, right? If we think about a data set and we kind of think about it on a number line, right? We have some min value, we have some max value, and then we have the range, right? So what we know, right, from the formula is that the range equals the max minus the min. All right, and that is definitely technically the formula for the range. But we can also think about it this way, right? We can think about the fact that if we were at the minimum, to get to the maximum, we'd have to add the range. Or if we were at the maximum and we wanted the minimum, we'd have to subtract the range because the range is literally just the distance between them. So, we could literally write formulas down like that. We could say, well, the max would be the min plus the range, and likewise the minimum would be the maximum minus the range, right? So if I'm sitting right here on a number line and I want to be over to here, well, then I'll take this and I'll add the distance between them. On the other hand, if I'm here and I want to be over here, I'll take this and I'll subtract. Well, what do we know? We know that the maximum, right? The maximum is 59. We know that the range is 27, so the minimum is going to be the maximum minus the range. So the minimum had to be 32 degrees Fahrenheit, right? Obviously, the freezing temperature of water. I just thought I'd point that out. It has absolutely nothing to do with the problem. But, never hurts to remind ourselves of an important number in science. 32 degrees Fahrenheit, the freezing temperature of water. Anyhow, let's wrap this lesson up. When we're trying to answer a statistical question, we often use what are known as statistical measures. What we saw in the last lesson were measures of the center, right? Things like the mode, the mean, and the median. And they are fantastic numbers when you want to summarize a data set. But when you want to talk about how much variation there is in a data set, then you need other types of measures, and there's a ton of them. But the only one you're going to learn in this course is the range. Simply the maximum value minus the minimum value, all right, which physically gives us the distance or the width of the data set when plotted on, I guess, a dot plot or a number line or however you want to think about it. The range is a fantastic thing to give if you really want to know that variation. And I like that last problem actually, because it's really kind of cool to be able to say, well, the average high temperature in March is 54 degrees Fahrenheit, but there's a range of 3 degrees Fahrenheit in temperatures or whatever it was, right? Because then that tells you, wow, there's a wide spread in high temperatures in March. March comes in like a lion, goes out like a lamb, that whole, phrase, if you've even heard of it. Most of the time in upstate New York, it still is going out like a lion as well. Not the point. The point is that range is a wonderful way of measuring variation within a data set, even if it's a very kind of simplistic way of doing it. All right, we'll see the range a little bit more in future lessons. For now, I just want to thank you for joining me for another NGen Math 6 lesson, getting tongue-tied, another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.